So the next thing we're going to do is take a look at how to evaluate limits numerically from tables of values. You're going to need that sheet titled Section 1.2, Numerical Limits In-Class Practice. In problem number 1, I want to find the limit as x approaches 2 of x squared minus 2x over x squared minus x minus 2. And I'm going to think about this the same way I thought about those graphical limits. First of all, I have a table of values over here. I've got a bunch of x values that, as we see, are starting at 1.9 and then getting closer and closer and closer and closer to 2. I then have 2, and then starting at 2.1 and getting closer and closer and closer to 2 in the other direction. The f of x values, or the y values, just came from taking these x's and plugging them into this particular function. We'll do some plugging in at a later time. Right now I figured it would be a lot easier if I just gave you a filled-in table of values. So my question here is, as the x's are getting really close to 2, what's happening to the y's? Well, I don't really care about what's going on right at 2, so I'm going to cover up that value. As my x's get close to 2 from the left, getting closer and closer to, looks like about 0.6666, about 0.6 repeating. Looks like the same deal from the right, 0.67, 0.67, 0.66, 66. Yeah, it looks like I'm getting close to about 0.6 repeating from both sides. I'm going to say that's my limit. Or we can be fancy and write it as 2/3. I didn't ask this here, but if I did ask you to find f of 2, what is the x value right at 2? Well, there, I don't care about anything on the table except where x equals 2. And there's nothing there, so that is undefined. And then I just want to figure out what exactly this is going to look like on my graph. Is my graph continuous? Is there a hole? Is there a jump? Is there an asymptote? Well, you know what? Let me try to draw a really basic graph of this thing. I've got x equals 2 over here. As I get close to 2 coming from the left, I'm a little bit below, let's see, I'm going to say 2/3 is over there, a little bit below 2/3, getting closer and closer to it. As I approach 2 from the right, I'm a little above 2/3 and getting closer and closer to that. And then right at x equals 2, there's nothing there. There's a hole on this graph. I'm going to have a hole when there is a limit, but my function value doesn't exist at that particular place. That's what's going on in number 1. Let's take a look at number 2. I want to find the limit as x approaches -1 of, looks like the exact same function I had in the first one. So I'm going to plug in values that are to the left of -1, -1.1, then -1.05, -1.01, -1.001, again getting closer and closer to -1. And same on the left, same on the right, I'm going to start at -0.9 and then plug in values getting closer and closer to -1 from that direction. Let's see, so my y's are going from 11 to 21 to 101 to 1001. Okay, that's kind of strange. This means really small changes in my x's are leading to kind of large changes in the y's. Very small change in the x, even bigger change in the y, really, really small change in the x, huge change in the y. The same thing's going on the other side. Small changes in my x's, but the y's are changing by a whole lot. So let's see if I can kind of graph what's happening here. When you're a little over there, you're at you're at 11. And then over at -1.05, we're at 21, so like that. Then 101, like that. Then 1001, way off the screen. It's going way up really fast. Coming from the right, well, I'm going to start at about -9, and then jump down to -19, -99, -999. Going down really fast. This is what your table is going to look like when there's a vertical asymptote, when small changes in the x's lead to really big changes in the y's. There's a vertical asymptote happening there. What's the limit? Well, there is no limit. That limit does not exist because I'm going way up to the left and way down to the right. Doesn't exist. I would like you to take a look at number 3, and I want to see if you can figure out, first of all, what the limit is, And then second, what's going on the graph? Is it continuous? Is there a hole? Is there a jump? Or is there a vertical asymptote? Well, let's see. As I'm getting close to 3 from, I don't care about what's happening right at 3. As I'm getting close to 3 from the left side, looks like it's getting kind of close to 1 for a y value. Same as I'm getting close to 3 from the right side, I'm going to say my limit is 1, which actually is the same as the value of the function there. So it's kind of like, let's see, I'm getting close to 1 there, getting close to 1 from the other side, and f of 3 equals 1. Kind of like what I had in number 1, but filled in rather than an open circle there, which means my graph is continuous at x equals 3. See what you can do in number 4. See if you can find the limit and also figure out the significance. Okay, limit as x approaches 1 of this piecewise function. Okay, well, as I get close to 1 from the left, looks like my y's are getting pretty close to, looks like 3 over there. As I get close to 1 from the right, 0.21, 0.0211, 0.002, looks like I'm getting pretty close to 0. I'm getting close to numbers, but they're two different numbers. And because I'm getting close to 3 from one side and 0 from the other side, this limit does not exist. And what's happening on the graph over here? Well, let's see. I'm getting close to 3 as I approach it from the left side. Getting close to 1 as I approach it. It's not 1, sorry. Getting close to 0 as I approach it from the right side. F of 1 is 0, so it's filled in over there. I've got to jump. I'd like you to take a look at the back of this sheet. We're not given a formula, we're just given a rather lengthy table. And I'd like to see if you can find these 4 limit values, and also tell me what's going on the graph. Is the graph continuous there? Is there a hole? Is there a jump? Is there a vertical asymptote? See what you can do here. So number 2, if I ignore what's happening right at 2, looks like if I'm a little left of 2, I'm getting close to 7. From the right side, my y's are getting close to 7. Ignore what happens like further away from 2. I'm going to say that limit is 7. Let's see. We're getting close to 7 from one side, close to 7 from the other side, but it doesn't exist over there. There's a hole on that graph. The limit as x approaches 4 of this function. So again, I'm going to kind of cover up what's going on right at x equals 4 for right now. When I'm to the left, looks like I'm getting close to negative 2. From the right, looks like I'm getting close to negative 2, so I'm going to say that limit equals negative 2. Let's see, I'm getting close to negative 2 there, close to negative 2 from the other side, and it's filled in over there. My graph is continuous at x equals 4. Limit as x approaches 4.5. Okay, well, as I'm getting close to 4.5 from the left, 5, 10, 100. Oh, those y values are going up really, really fast while the x's are changing by just a small amount. That pretty much tells me there's going to be an asymptote. Yeah, same thing on the other side, negative 8 to negative 45 to negative 89. There's a vertical asymptote there, and that limit does not exist. Vertical asymptote. Finally, taking a look at the limit as x approaches 8. Again, I don't care about what's happening right there at x equals 8. When I'm to the left, negative 3.45, negative 2.89, negative 2.01, I don't know, maybe I'm getting close to negative 2. From the other side, 2.357, 1.956, 1.895, really not sure, but it's not negative 2. And these y values are not going way up or way down very, very quickly. Either way, I'm approaching different things from the two different sides, so the limit will not exist. And there's a jump there. And that's all I have for this video.